Okay, so today we have Ricardo. Ricardo is working on the eROSITA data, and I just invite him to explain a little bit about the eROSITA Data 1 release. And okay, so
I'm happy to talk about eROSITA for a few minutes. So eROSITA is an X-ray telescope aboard the SRG satellite. This was launched in 2019 and it has been operating since then. And it's currently revolutionizing our view of the sky in X-rays. This is because of a combination of a few different factors, like its ability to scan the sky very quickly, its large field of view, and its relatively good resolution. So this allows us to map the sky, the whole sky in about 6 months with a resolution and a precision we really never had before.
okay, you can just scan the entire sky within
Within 6 months.
Wow, that's really fast. Yeah.
Yes. The data release we had last week is about the first passage of the sky. Up to now, we have more than 4. And the data of the first one was reduced, analyzed, and made public last week, together with about 40 papers from the collaboration. So
yes, we see from archive. Yeah, that's a lot. Yeah.
And so maybe we can take a look at
Okay, sure.
At this image. So this is the image of the first eROSITA Sky survey. So in this projection, we have the galactic center in the middle, and in the center of the panel, we have the galactic plane. The color coding depends on the energy of the photons. So we go from low energy in red and then progressively to higher energy X-ray photons in green and blue.
Okay, so this part is a very high energetic.
Exactly. So this is the galactic plane. So in this area, what happens? We have a lot of dust and gas that absorbs the softer X-ray emission with low energies, and so what's left and what we see is the high energy photons. I think by looking at this image, the most prominent feature you can see is the eROSITA bubbles, 2 big bubbles here. And these are particularly interesting because also together with the harder emission in green, maybe here a bit more towards the center, they encode so-called feedback processes related to explosions of supernovas, so massive stars at the end of their lives, and especially to past activity from the supermassive black hole in the center of our galaxy that is now dormant.
So if you are a cosmologist, you see this area instead of the central
Exactly.
part.
Yes. Yeah. So then maybe we can move to the next image because this shows the entire sky, but eROSITA is actually a consortium. It's a collaboration between 2 different consortia in Germany and Russia. And they own different halves of the sky. So the data release we had was for the German consortium that owns the western side of the galactic sky. This is the image that was actually in press last week. Yes. So now the galactic center is here on this side. You can still see the eROSITA bubble. And in the center you have this is a supernova remnant, this is the Vela supernova remnant. So what's left after explosion of a massive star. And there have been some dedicated studies to this object in particular. So now if we move outside of the galactic plane, in the image you see a multitude of tiny little dots. And these are, all the dots, all the tiny little dots. Right. These point sources are AGN, active galactic nuclei. So supermassive black holes that are accreting huge amount of matters and emitting X-rays. And they are actually most of the source catalog, more than 80%. About 710,000 AGNs were detected in ERAS-1. Yeah. And the whole source catalog is about 900,000 sources, which is by far the largest X-ray catalog we have to date.
So right now for astronomy community, we not only can see this kind of image, but also we can access the data for
Exactly.
for this
Yes,
one.
there is a portal where it's possible to download all the files with the events, the images, and all other maps that are important for data reduction and data analysis.
Okay. So which kind of science we can study from this X-ray emission?
eROSITA was to do cosmology with clusters of galaxies. So also in the image you can even see by eye some more extended sources. For example here, this is the Virgo cluster. Also this one, this is Fornax. This is another cluster. And so these are large collection of galaxies that are filled with hot gas, very hot gas that emits in the X-rays. For example, if our universe contains very large amount of matter, this would make, in a certain sense, gravity's job easier in collapsing these perturbation into halos, which would mean that we could see a very large amount of clusters and very, very massive clusters, just because the structure formation process has been very efficient throughout cosmic time. Let's say on the other end, we also have dark energy, so this mysterious component that is causing this accelerated expansion of the universe. This instead goes against the collapse and makes gravity's job more difficult in collapsing matter into halos, which would end up in a lower amount of these clusters we can observe. So basically, counting these clusters in terms of their mass and their distance away from us, we can put constraints on these fundamental cosmological parameters such as matter abundance in the universe and properties of dark energy. It's quite exciting. And actually, there will be a dedicated release with the cosmological results next week, on Wednesday next week, I believe. And that will be very exciting, I think, for the whole scientific community and people interested in cosmology.